Welcome to Temple AK Academy, and in this video we're going to study approximations. Approximation is simply a way of expressing the result of a computation in a more convenient form. So the keyword or the main principle is convenience. Convenience in the length of the number of digits the number has. Let us consider the evaluation of 3/7 conversion into the fraction 3/7. We may convert the fraction 3/7 into a decimal. We get a chain of digits the usual way. There is the video on fractions, so you can find that video on this channel and study. So we have 0 points, an arrangement of digits 4, 2, 8, 5, 7, 1. You can see the digits keeps growing. Another round of 4, 2, 8, 5, 7, 1, and so on. So there is no end to this. You can see the recurring digits 4, 2, 8, 5, 7, 1, and you can see it again 4, 2, 8, 5, 7, 1. So it keeps going that way, and therefore there is a need to truncate the keyword, truncate or cut off. Truncate. So truncation is the main operation in approximation. Truncation. So that means to cut off at a given number of digits. So if we cut off after 2 digits after the decimal point, we will get this figure will be approximated to 0.42. So in this video, we're going to study the different ways of approximating numbers. So let us get into it. Right. First is the number of places of decimals. Number of decimal places. The number of decimal places is simply the number of digits after the decimal point. And there are special rules that we obey, the rules of rounding up. The rules of rounding up. So if a digit is up to 5, or more than 5, we round it up to 1 into the next digit. So the rules of rounding up and the rules of rounding down will be obeyed. If a digit is less than 5, then we have to round it down to 0. So rounding up and rounding down, 2 important processes that we must follow. Let us get into illustrative examples very quickly. So here we have, let us express, first of all, let's express 3.142. 3.142. So 2 decimal places. Let's have 2 decimal places. The first thing to do is to check the decimal point position and then 2 digits after that position. First is 4, first is 1, second is 4. After that digit 4, the next digit showing up is 2. So that is the truncation point. We must have to cut off after that position. So the digits after the truncation point is 2. And because it is less than 4, we'll round it down. And that means this digit will be ignored. So our final answer will be, and this is going to be 3.14. So 2 places of decimal, our final answer. That's very simple, of course. Let us consider a second example. So let us express 72.3125. 72.3125. 72.3125. So 2 decimal places. Let's have this. 72.3125. 2 decimal places. Let's locate the position of the decimal. That's it. And now 2 digits after the decimal point position. Let's go. 1, 2. And that means we already have our truncation point. We're going to have to cut after that digit. So we have that's our truncation point. Yes. And immediately after the truncation point, the digits we see there is 2, which is not up to 5. So we have to round down. That means our final answer will be, this is equal to 72.31. That's very simple. So we have a more convenient writing. Now, let us take one more example, the final example in this series. Let's go 310.7259. Let's start this. So we want to approximate these to two decimal places. Now the decimal point position is clear. And let us now have two digits, 1 and 2. So we can see clearly our truncation point. Our truncation point is going to be right there after the digits 2. Yes, we're cutting off. The next digit, therefore, being 5, requires us to round up. So the 5, we have to raise these digits 2 up into the next digit, which is 3. Raise 2 up into the next digit, and that is 3. So we have our final answer, and that's going to be 310.73. No more 2 there. The 5 is able to round it up into 3. Very simple. And as a caution, I just want to give the last addition as a caution. Sometimes we do not need to go by multiple or double approximation. Let us see what I mean by that. 243.6549. 2 decimal places. Let's see this. So 2 decimal places. Okay, of course, that's the position of the decimal point. And therefore, let's count 2 digits after that position. We have 1 and 2. So, of course, we can see clearly our truncation point. Truncation must occur after the digit 5, of course, that point. So we're cutting off there. Now we inspect the digits immediately after the truncation point. It is 4. Being 4, less than 5, it lacks the capacity to round the 5 up, and therefore all other digits will be left. So our final answer will be, this is equal to 243.65. It stands that way. Very simple. So avoid the common mistake. This is the correct answer, of course. Avoid the common error, which is the error. And that's what I want to correct in this video. The common error, which is the concept of over approximation. You have 243.6549. So avoid the error. 2 digits after the decimal point highlighted. And then don't make the mistake of considering the 9 to approximate the 4, making 5, which is in turn approximate the 5 into 6. And that will be wrong. To write an answer like 243.66 will be incorrect. This is multiple approximation. All right. So let's get into the next area. Number of significant figures, of course. Number of significant figures. These are simply the digits that are taken into consideration in any computation. So we see some rules. Number 1, the chain of initial zeros are not significant. So initial zeros, I call them leading zeros. They are not significant. A chain of leading zeros are not significant. So if you have a number like 0.000065, this is simply 2 significant figures. This number is simply written into 2 significant figures. 2 significant figures. This is because this initial chain of zeros are just not significant. So this initial chain of leading zeros are not significant. Number 2, terminal zeros are also not significant. Terminal zeros, chain of terminal zeros. Chain of terminal zeros are not significant. Okay, so we're talking about terminal zeros, we mean the ending zeros. So a chain of ending zeros is simply not significant. ending zeros. So we have something like 7, 2. Then we have a chain of zeros. This number is simply written to two significant figures because the chain of ending zeros are simply not significant. These terminal zeros are not significant. So this number is written to two significant figures. Now, along the line, in the course of this video, we're going to see situations where we can make terminal zeros to be significant. We will see that. Now, however, intercalating zeros, that is zeros sandwiched between significant figures, are actually significant. So sandwiched or intercalating zeros, sandwiched. We sandwich a zero, then it is significant. For example, 7.1025. This zero in between is significant. So this number is written, so all the numbers here are significant. 1, 2, 3, 4, 5. So this is 5 significant figures. Let's look at another one. 3.0002. Here comes a chain of sandwich zeros. So these three zeros sandwich in between the first digit 3 and the last digit 2 are actually significant, making this 1, 2, 3, 4, 5 significant figures. So this is written 5 significant figures. That's right. So let's just go and, however, the rules of rounding up and rounding down are still going to be applied here. So rules of rounding up and rounding down are still welcome here. Rounding up and rounding down are welcome as rules, up or down. They're welcome here. Okay, let us consider some illustrative examples very quickly. All right. Let's express the following numbers, the three significant figures. Let's go for the first one. The first one, 1.2346. Three significant figures. 1.2346. Let us express this to three significant figures. Now we have to count the digits. The initial one, significant, 2, and then 3. So we have a truncation point from this already, and here it is. After the digit 3, we have to plan the truncation. That is cut off to a convenient form. And this is going to give us, roots of rounding up or rounding down. The 4 immediately after the truncation point is not up to 5. So it cannot approximate or raise this 3. So our result, final answer will be 1.23. This is 3 significant figures. That's right. Very simple. Very simple. Let's look at another example. The second example is 0.3, 2 zeros to follow. 0, 0. Now 865. 7, 2, 8, 6, 5. Let's approximate this to 3 significant figures. Now, as discussed earlier, this chain of initial or leading zeros are not significant. So our counting will start from the significant digits. 7 is significant, 1, 2, and of course 3. So we already can figure out the truncation point. That is the truncation point after the digit 8, 6. The 6 is up to 5, even more than 5. So we can use it to round up the 8 to become 9. That means our final answer will be 0.0072, no longer 8 here, but now 9 because of rounding up. Our final answer. 431.795. Now the position of the decimal point is not shown. All right, so how do we handle this? 3 significant figures. Let's count our first 3 digits that are significant, of course. 1, 2, and 3. So we have a truncation point already. That will be the truncation point. Yes. So we intend to cut off immediately after 1. But there is no decimal point here, as you have noted. Therefore, these 3 digits cannot be lost because then the magnitude of the original figure will change drastically. So we end up writing 4, 3, and then because the 7 after the truncation point is more than 5, it can round up this one to become 2. And if we cease writing at this point, we are simply changing 431,795 to simply 432, which would be incorrect. So the digits after the truncation point will become zeros because there is no decimal point in this particular case. Very simple. Now let us take one more. 1, 3, 4, 7, 9, 6.26. Now let us take to 3 significant figures. These to 3 significant figures. Let's count the first 3 digits. 1, 2, and of course 3. And now we have the truncation point already, so we want to cut off the digits at that point. That's the truncation point. So the digits after the truncation point is 7. What do we do? This is more than 5 already, so it will round up 4 right there to become 5. And we have our final answer already. So this is going to become 1, 3, 5, the 4 being rounded up into 5. Now the digits that are before the decimal point position will become zeros. And the digits after the decimal point position will simply be left out, our final answer. I would like to add about 3 more examples just to portray this so that the learning is perfect. So let us consider 3 more examples. Now I have to take the traces off. Let us consider 3 more. So 3 significant figures. The next example, 216849. What do we do with that? 216849. 3 significant figures. Where are our significant digits? 1, 2, 3. 3 significant figures, of course, that's it. So we can set up truncation right now. So truncation point is right there after 6, in between 6 and 8, our truncation. If we do that, go ahead and truncate, we're going to have 2, 1, 6. And now inspect the digits after the truncation point, which is 8, is more than 5 already. That means it will round up the 6 into 7. So actually need to write a 7 there. Yes. And there is no decimal point around. All digits after the truncation point will return to zeros. So the magnitude is preserved. Final answer. Very simple. Let us look at the next one. The next 129.78. 129.78. Let's see. 3 significant figures. So we have 1, 2, and 3. And now let us see. After the first 3 digits, we can have truncation immediately. So the truncation point is exactly on the decimal point position, as you can see. And the digits after that truncation point is 7, which means it can round the 9 up. And now when a number ends in 9, you have to consider the 2 digits together, 29. If you round 29 up, increase by 1 unit, you get into 130. And that's it. The numbers after the decimal point will simply be left out. Our final answer. Very simple. Okay, so let us go into the next stage. Go into the next stage. Nearest whole number, for which I have to take these traces off. Nearest whole number. When you want to express a number to the nearest whole number, it means the truncation point should be at the decimal point position. So the rule for nearest whole number is that the truncation point is at the decimal point position. The truncation point is at the decimal point position. All right. So let us buttress this with some examples. Let's express the nearest whole number. The first example, 123.4. The same principle as we have studied. The truncation point is exactly the decimal point. let's go. We're planning to cut off at the position of the decimal point, which means we can now observe that the next digit after the cutting is 4. It's not up to 5, so it will be rounded down. Our final answer can easily be written right now. And this is going to be, it is equal to simply 123 to the nearest whole number. So this is the nearest whole number, 123. Let us consider the second example. Let's go. 962.832 to the nearest whole number. Once again, the truncation point is exactly on the decimal point. Fine. And now we have to inspect the next digit after that truncation point. It is 8. 8 has the capacity to round the 2 up into 3. And now we can confidently write our final answer. So this is going to be 963, our final answer. Very simple. So the rule, once again, the truncation point is at the decimal point. Very, very simple. Let us move on into the next area, for which we have to take the traces away. Now, we have to take this to important step right now. If you have not already subscribed to my channel, please do so now. And then above all, turn on the notification bell so that you can get the alert when I make a new video like this. And please continue to like and share this video so that you can help others to learn and also help to grow this channel. And thank you very much. I appreciate that. All right. The nearest 10, nearest 100. So let's look at some examples. We want to express the nearest 10. Let us express 42.36 to the nearest 10. We have to look at the place value of the individual digits. So this is the unit digits. And that's the 10 digits, unit digits. So if we want to write this to the nearest 10, we're looking at 42 there. Can you see that? So the truncation point is actually after the 10 digits right there. So truncation point is between 4 and 2. So we simply want to write. But immediately after the truncation point, we look at the next digit, which is 2. That 2 doesn't have the capacity. It doesn't have the capacity to round the 4 up, which means we're simply going to write our final answer as 4. The 2 being in front of the decimal point will become a 0. And then the digits after the decimal point will simply be left out. They are after the decimal point. So very simple, and that will be our final answer. That's right. Very simple. Let's take another example to purchase it. Express to the nearest 10, to the nearest 10, 227.865 to the nearest 10. Okay, this is the unit digit. This is the tens digit. And this is the hundreds digits. So hundreds, tens, units. That's right. Now, if we want to express to the nearest 10, then the truncation is in between the tens and the unit digits. So we have the truncation point right there. Yes, and the digits after the truncation point, we can see clearly, and that is 7. It has the capacity, of course, being more than 5, it can round the 2 up into 3. So we're going to have our final answer written. This is going to be 2. And this 2 is already rounded into 3. The 7 being before the decimal point becomes a 0. And then all digits after the decimal point, namely the 8, 6, and 5, will be left out of the final writing. And this becomes our final answer. Very simple. That's the nearest 10. Okay. Let us take one final example. What if we have this situation? 139.48. 139.48. Once again, we have to recognize the place values of each of the digits. This is the unit digit. That's the tens digits. And of course, the hundreds digits. So the nearest 10 is between tens and unit digits. I have to use another color of pen for that. Yes, that's the truncation is going to take place around it. And now, careful at this point, because the next digit we see is a 9. Once you have a 9, then you have to consider the two digits, 39 there. And then 39 will be rounded up into 40. So we have our final answer can be written. 9 has the power to raise this 3 into 4. So we have 1, 4. Being before the decimal point, we have a 0, and the digits after decimal point can now be left out. Yes, those at the back of the decimal point are not welcome in this writing. Final answer. Very simple. All right. Now let us express to the nearest 100. To the nearest 100, 123.79. 123.789 to the nearest 100. So we want to go to the nearest 100. We have to highlight the place value of this digit. So this is the unit digit as of length, tens digits, hundreds digits. That's right. So to the nearest 100, the truncation point is right there between the 100 and the 10 digits. Let me use another color of marker for that. So between the 100 and the 10, that's the truncation point. Correct. And now the digits after that is 2, which is less than 5. So we can already see that we're going to round down in this case. So our final answer will be 1. The 2 being less than 5 is not able to round up the 1 into 2. So it will be left out because it is in front of the decimal point. So 0, 0 for the 2 and 3. And then digits after the decimal point will simply be left out according to our operating principle so far. Very simple. That's our final answer. Another example to go to the nearest 100. And this will be the final example for the nearest 100. So let's go for 6325, 46325.871. Now let us give the place value of these digits. This is going to be the unit digit. This is going to be the tens unit digit. This is going to be the 100 digit. That's going to be the 1,000 digits. So we already have the 100 position, and that's it. So truncation is going to happen right there between 100 and tens digits. We want the nearest 100. So that's it. Beautiful. Now, immediately after the truncation, we see 2. It doesn't have the power to affect the 3 by rounding up. And now we can already write our final answer. And our final answer is going to be 4, 6, 3, the way it is. And the digits now before the decimal point will return to zeros. 2 of them will return to zeros, 0 and 0. And finally, the digits after the decimal point will simply be left out. This is the final answer. Very simple. Now, let us continue, move on to the next stage. Let's get these traces out of the way. It's very interesting, really, very, very interesting. Nearest 10th, 100th, etc. So let's see the first example. To the nearest 10th. We want to express the nearest 10th. Let's express the nearest 10th. 1.7863. 7863 to the nearest 10th. 10th. So 1 to the nearest 10th. Now we have to get the place values of each of the digits here. 10th. After the unit digits, the digits after the decimal point, we have the 10th digit, the 100th digit, and the 1,000th digits, and so on. So the 10th digit right there. So our truncation point is simply going to be towards the right now, in between the 10th and the 100th digits. That's our truncation point, of course. Now we have to inspect the next figure after our truncation point. That's 8. It has the power, of course. Now it's going to raise the 7 by rounding it up into 8. And we can already write our final answer. So here we have 1.8. All other digits being after the decimal point will simply be left out of the presentation. It is more convenient to carry 1.8 than the chain of 1.7863. This is the principle of approximation. Convenience. Okay, let us take the next example. Express in the nearest tenth. In the nearest tenth, 73.647. Nearest tenth. Let's see. How do we proceed? After this place values, units, digits, tens digits, hundreds digits, and that is tenth digit, that's tenth, hundredth, that's hundredth digits, and thousandth, and so on. Now we want to approximate this to the nearest tenth. So we can see the tenth digit already. So in between the tenth and the hundredth will be our truncation point. Yes, that way. Truncation. Inspect very quickly. 4 is the next digit, so it totally lacks the power to round 6 up. And now we can have our final answer. So we can already write our final expression is 273.6. Our final answer. Now let's have the next example on the nearest hundredth. So we want to express to the nearest hundredth. So I'd like to take these traces away. Nearest hundredth. Let us take these traces away for now. Yes. Now for the nearest hundredth, let's go. Nearest hundredth. Let's go. 12.5, 7, 8, 6, 4. 5, 7, 8, 6, 4 to the nearest hundredth. Let us take a look. So for that, we have to quickly assign the place values. This is the 10th position, 10th digit, hundredth, thousandth, and so on. So if we want the nearest hundredth, our truncation point, of course, will be just select 100th to the right of it, and that is the truncation point. Now the digits immediately after the truncation point is 8. It has the capacity to round up this 7 into 8. And we can already write our final answer. Our final answer is going to be 12.58. Very simple. Nearest 100th. This is nearest 100th. And finally, we can take 1.8659. Nearest hundredth. Let us look at the place values. This is the 10th digit, that is the hundredth, and that is the thousandth digit. So the truncation point is in between the hundredth and the thousandth. And now the next digit is 5, which has the power to round this 6 up into 7. And we can already write our final answer. This is going to be 1.87, our final answer. All right. Thank you very much for being part of the session. If this video has blessed you, please like, share, and subscribe to my channel. Turn on the notification bell. Continue your practice, and that is the only way you can attain perfection. Until I come